Good morning, everyone. Today's Tech Talk session is by Bakthi Kamburawala. He will be speaking on microservices architecture with Spring Boot. So over to Bakthi.
Okay, thanks, Irina. Good morning, everyone. Thank you for joining in. This Tech Talk is about microservice architecture and how we relate that to Spring Cloud, which is one such implementation of microservice stack, so which we basically use for million spaces. So we have used this stack for million spaces. So we thought of presenting you guys what we use there, how it maps to microservice elements, because I think Krishant has already done quite a bit of theory part. So this is in this Tech Talk, I'm going to relate those theories into Spring Cloud elements. But keep in mind that Spring Cloud is not the only way to implement the microservice. There are lots of other vendors and frameworks which are out there. So because some clients actually prefer to have certain frameworks, some just have different favors. But we have to choose the stack carefully with considering all of that. But in Million Space, we had the luxury because it's our product, so we can choose whatever we are mostly comfortable and whatever the tech stacks that we needed. But in certain cases, people actually, the clients actually will ask you to select certain that some prefer cloud service based architecture, some preferred Kubernetes and so forth. So likewise, there could be a lot of variation with the customers, but I think as Krishant mentioned, the theory is more important. So if you know theory, how the microservices works and how you actually break that into domain microservices, etc., I think you could anyway come up with a better architecture. So with that, I think I will go through the agenda. So this is the first Tech Talk on 1 billion technology slide deck, I think, as you all can see. So agenda for the Tech Talk is today's. So first I'll go through all of these items. The first Spring Boot, and then the Spring Cloud Netflix stack. And then we have Spring Cloud reference architecture diagram. And then in that diagram, there are lots of elements which actually helps you to construct the architecture, so which consists of, I think, service registry, which we use Eureka, and the API gateway as in Zuul. In the service communication, there are two ways. So one is synchronous, the other one is asynchronous. I think Prashant has covered all of the theories. I think that certainly helps me to, and even helps you guys to understand better of these components. And the circuit breaker as in historics, and there's some concept called client-side load balance. So I think you all guys know what is server-side load balancing, but this is about client-side load balancing. We use Ribbon for that. And then finally, we're going to present you the million space architecture, how we actually did all of that, how we use all of these components together to build up the million space architecture. So let's start with Spring Boot first. So I think Spring Boot, as you all know, it's more related to Java stack. So if you're familiar with Java stack, probably you may be knowing it. But other than that, for those who are not familiar with Spring Boot and Java stack, I'll explain what Spring Boot is. So it's like Java library or the framework provided by Spring for basically to do the rapid application development, which means that you can build and deploy application much faster and with less time. So I think so that gives you a lot of freedom to developers to do less coding and build application and test it. So it's a Spring. It's a part of obviously Spring framework, and then it just allow you to build application easier and faster way. So that includes web applications as well. So it creates basically a standalone Spring Blade application, which means that it actually run its own. It's acting as a container or a small a web server kind of thing, and where it can run its own. So if you see that it needed like Spring framework, and it has embedded Tomcat and Jetty. So we can choose which server that you wanted it to be run. So, but most of people use Tomcat, but you can use Jetty as well. And then, so usually when you start a container or an application or even web server, so you have to do a lot of configuration, XML configuration as such. So here, so that's why the minus is there. If you see Spring Framework plus a web server, Tomcat or Jetty, and then the minus is you don't have to do any configuration as such for you to start a boot application. And the other thing that I want to tell you is boot actually is not only for microservice application, because some people actually even use boot for other applications as well. So but in boot, like, it is ideal case because it actually supports you to deploy it in a container, and you can start it as a lot of isolated boot containers which does certain. So typically you can actually map your microservice to a boot container or even multiple boot containers. So let's see what are the advantages or why we need the boot. So as you all know, especially if you know Java, there is something called dependency injection approach. So I'm not going to talk about too much on dependency injection because it's a different subject altogether. But if you learn Spring, I think you will get to know that this dependency injection is. So Spring Boot supports that. And then there are other advantages, like it supports actually powerful transaction management capabilities. It has like JPA, Hibernate, and other ORM, structs, MVC, and all of that. So you can use, you can get use of all these, or you can plug all of these technologies much easier if you use Spring Boot, because it comes as a total package. So, and it certainly reduce cost and development time, because most of these frameworks and libraries are done most of the stuff, which, you just have to basically configure or just write the business logic itself. So other boilerplate codes and everything is available along with the Spring. And I think I already explained it can run its standalone application. It can run its own, and it actually supports HTTP servers such as Tomcat, Jetty, and you don't want to deploy WAR file. Traditionally, you guys know, like if you want to run something, then you have to create a WAR file and then deploy it to a web server or app server. So here, so you don't have to, do that if you use Spring because it's automatically given for you. And it also comes with certain metrics, health checks, and externalized configuration for you to manage these containers much better in production environment especially. And there is no requirement for XML configurations. And then offer a number of plugins along with that you can use, and certainly it helps you to increase the productivity of the development of time. And then if you move to Spring Cloud, so this basically focus on the microservice. This supports the microservice-based architectural concept like distributed version configuration, service registry, and service discovery. So don't worry, I will explaining all of these items in my later in my slides. I'm just here mentioning what are the focus areas or features that provide in cloud routing, service to service calls, load balancing, circuit breakers, and distributed messaging. So this Spring Cloud Netflix. So as you all know, Netflix is wider. The big company which actually provide you a lot of streaming and stuff like that, the videos over internet. And I think they are the one of these founders of Netflix stack, which basically I think it has been there for so long. I think since 2011-12 they have started building this stack for themselves, so that when they use microservices and stuff like that, it will be easy for them to use this stack. And then finally they actually convert that to a open source project, and now it has been used by lots of other communities and people, and it's actually a well-tested open source framework available for you to do. It actually comes with a lot of elements that helps you to build microservices much faster. So I think as Krishanta has already done the theory aspect of it. If you see the table in your left side, you will see the basically the concepts, and then the right side, what are the map features which are available in the Netflix stack for you to actually rather implement or build. If you're planning to build microservice, so what elements or components available for you to implement those patterns, which was explained by Krishant some time ago. I think one is the service discovery. So that's actually Eureka, this Eureka server, which actually does that capability. API gateway, this Zuul. Central configuration, Spring has its own config server. Dynamic routing and load balancing, it has ribbon. Circuit breaker, historic libraries there for you to use, and also for you to actually monitor how these containers are behaving, how the services are up and running, whether they are do some health checks if they are up and running. So all of that there is a dashboard available. Even Eureka has its own dashboard as well for you to actually monitor what is happening, what services are up and running in which ports, which IP addresses and so forth. You can monitor all of that. And as I mentioned, I think in the earlier slides, so service discovery. So in Eureka server, so when you actually start a instance or a microservice, it can. So this Eureka in this Eureka server, it get registered, and then clients can discover, okay, what are it's basically a lookup kind of service where if any other service wants to communicate, or even external services, like for example, if an API call happens, so it actually look up what are the services available. Even there could be multiple services, right? Same container or the service could be even replicated due to high availability and improve the performance. So in that case, there could be even multiple versions of the same service. So then it will actually give you do a bit of load balancing task as well. So it will actually gives you out of, let's say, if there are 3 services running, so it will give you one particular service which can be invoked. So likewise, it can do a load balancing as well. So anyway, I will be explaining all of that in a later slide. So let's look at, so if you are using Netflix stack, this is a typical or most simplest architecture one could have. There could be even much more complex architectures depending on your requirement, but I think this could be the most simplest. I would say these elements must be there if you're using Netflix stack. So if you start with clients, could be even mobile client or the web clients, and then they all have to come through then API gateway. So in this case, it's Zuul. Because Zuul is the Netflix version of API gateway, and there is a load balancer as well, coupled with ribbon. And then the API call get hits first there, and then based on that, it will route the traffic to the relevant services. So as you can see, there are like business services, business service 1, 2, 3, like that. You could have multiple services or up and running. And even services themselves could be duplicated, right? Because of if there is a one particular service getting called so much of time, probably you want to scale that particular service. So that is typically, one major objective of, advantage of using microservice, because you can scale based on the demand. So then and the database. So database also be attached to one particular service set. So that is typical architecture. And then you have Eureka being act as a registry of all the business services and the dashboards for you to monitor the set of services. So I think any questions, guys, up to this point? Or shall I proceed? Hope this is clear. If there's anything not clear, just let me know. So let's talk about these elements in detail. So Zuul, so if you talk about Zuul is the API gateway. Sometimes they call it as edge server as well in Netflix stack. Or typically it's a API gateway. So if you know that Zuul is one of the, I think, blockbusters movie. There was a movie and this is one of the character. So it's actually a monster acting as a gatekeeper. So I think maybe somebody who actually developed probably liked that movie. So I think they probably name it as in this way. So basically, Zuul is a gatekeeper, which is a API gateway. So it actually, what I think most of you know what API gateway is. So it basically, I mean, it does a lot of things. API gateways, I mean, nowadays there's a lot of things. So one thing, one more main thing is it's actually not allowing you to have unauthorized external requests passing through. So you have to, I mean, authentication happening in the API gateway, and there are, and it will be a single entry point to the microservices. So you have, if you go to the previous slide, so you can see that there are lots of services running here, and so all the API requests has to go through the API gateway. So all the so you can write basically some sort of rules if you want to apply certain rules and routing rules. All of that you can configure in any API gateway, not only in Zuul. If you use any other API gateway also, those API gateways actually provide you those capabilities as well. So, but Zuul, why you have to use Zuul here is because it's go hand in hand with other component like the registry server, which is Eureka, and load balancing ribbon. So that's why you have to use Zuul for you to like get the maximum benefit. I mean, you can use any other API gateway as well, but here, so it actually the entire suits actually goes well hand in hand, and you can do a lot of things with if you're using entire stack. So the other one is the Eureka. So Eureka, what Eureka basically does is it actually allows you to microservices to be registered themselves. For example, in reality, microservices could go down, scale in, scale out. So based on that, what should happen is, so all these, when you scale in or scale out, you can't actually pretty much, hard code or it's dynamically change, right? So there should be some sort of somebody doing them registering services. So if there's a service goes down, then you have to deregister that service because that service is no longer available. And if there's a new service coming in, then you have to register, okay, what host and ports and so forth, and the details. So if anybody wants to refer a particular service, that they should always go through Eureka server, not like direct calls, as in direct calls, it will work, but it's not the best practice to do those kind of things because, server ports and even IPs could potentially change in a dynamic environment. So, Eureka server also known as discovery server because it acts as a information collection center about all the microservices that are running, basically the IP addresses and ports. So it also helps actually to do client-side load balancing, which I will be talking about later on, because it decouples service provided from consumer without need for a DNS. And the other important is inter-service communication. So I think Krishant has already mentioned in last slides, like you should actually design your microservice in such a way that, the intercommunications are minimized. But there are situations that you might have to do certain inter-service communication for you to get information from other microservices. So in that case, there are two types of inter-service communications: synchronous communication and the asynchronous communication. So when it comes, I think synchronous communication, I mean, in million space, actually we use both synchronous and asynchronous. I think, as Krishant mentioned, most of the, if you want to have reads, you could do synchronous. But if it is write, mostly you have to use asynchronous. So it actually, the Spring supports both. So Spring come up with the frameworks called Fission client. So Fission client actually supports you the synchronous communication. So I will explain again in detail on the later slides what Fission does. And the asynchronous communication, I think you have to definitely use a message broker to do. Spring also support, I think, RabbitMQ, Apache Kafka, or even AWS QS. So you can plug these messaging brokers along with this. So let's talk about little bit about message brokering. So if no one has done message brokering before, I think this will be helpful for them to understand. In high level, what a message broker does is, let's say a particular service wants to talk to another service, or even if a particular service wants to get some service from another service which are there in remotely. Mostly actually we use this in distributed communication, right? So in a remote service, if you want to consume a service, what it does is actually a service producer. There's actually two things. One is the producer and the consumer, and the broker in between. So producer, what it does is it actually invoke a message or the service in the consumer space. So basically they want to talk to each other. So what it does is then it actually calls the message broker, right? When you call the message broker, actually it generates you it gives you a acknowledgement kind of thing. It's not that the service has been fulfilled, but it is just an acknowledgement from the message broker, say that, hey, I have received your message and I'll do the needful for it to be reached to consume. So then what the broker does is it actually does the pass the message to the relevant consumer, right? So that's how it happens. And then when the consumer received it, it does whatever it's supposed to do. So that's how. Why the message broker is there is because we want to have the guaranteed. Whenever there is a guaranteed delivery is required, so message broker has capability and capacity to do that, because it can queue certain services. Let's say if the consumer is down for a certain period, then what message broker does is it actually keeps those requests and persists those requests. Even if the message broker get down for some reason, even those persist message will be there. Even if you restart the broker, then it will start sending messages to the consumers, and then even the consumer is down, so message broker keeps it and keeps on retrying. So in that way, it actually lets you do the guaranteed delivery. So it's actually, these are theories. These are not nothing about Spring messaging. So then let's talk about Fission clients. So Fission clients is basically used again for intercalls, service to service. So it's actually a REST-based. Basically, it supports REST. So if there is so usually what happens is these the communication logics and the communication error handling, all of that related to communication has been handled by the Fission. So it actually helps developers to just concentrate on business logic and decouple the business logic along with the communication sort of logics. So it actually helps developers to concentrate on business rather, boilerplate code and other error handling mechanism due to the communication. The REST communication, I think Fission's supports a lot of that if you use Fusion. Also, it actually helps you to avoid hard coding service URLs and so forth. Also, yeah. Again, it's here. This side also it's kind of explaining what it basically does. I think I've already exploding. And the other special feature is that you can encode, decode the messages in between also. I mean, that is also one of the advantages if you want to have secure communication. So those encoding, decoding also can be done through Fusion. I mean, it's just a tool or kind of library which actually helps you to do the communication in between services. And the next one is Hystrix. So Hystrix is yet another component of the library that Spring supports you to do the circuit breaking. So I think, so what circuit breaking is like, if there's, let's say, if you want to call a particular service and that if that particular service is not available, then you should have a mechanism to fall back. Okay, what I should do if that service is no longer available, or if the response is getting delayed due to some reason. So I think, so Hystrix will allow you to have write the fallback mechanism. So idea here is, in the circuit breakers you want to fail fast rather than somebody waiting for so long and say, okay, I have failed or I'm not available. Rather, I think with this you can actually do fallback you have to fall back very quickly rather than having to wait for so long. So you can even Hystrix allow you to do it in synchronously or synchronously, whatever way you want as well. I think so, guys. I think these components, I think you can even go dig deeper, like how you actually implement these services. I mean, what are the capabilities those libraries has? I think so that is going to be anyway like very, different. You can actually conduct different tech talks on each of these components as well if you really want. But I think in high level, I think I can't cover all of that in this thing. But I think what we are planning to do, I think me and Harshan, we have actually, even Prashant also told this some time ago when we actually meet our microservice group. I think we will be certainly discussing some of these topics in details on that forum. So we have a meetup schedule within the group. So anybody who is interested to learn much deeper on these aspects, I think can join for that microservice group. Right now we have like quite a few people joining microservice group. I think in future, I think most of these the applications are now going towards microservice, even with or without clouds, right? So cloud is also supporting a lot of microservice friendly services. So I think with or without, I think cloud services, I think it's going to be microservices moving forward. I think all of the applications will go, or not all, at least I would say 80% of the application in future will be on microservices. So I think it's better to learn at least what is out there, and so I think you guys can join in that group. I think we are planning to discuss those in details and in that forum. So let's talk about Ribbon as well. So Ribbon is a mechanism, I think it supports you to do a load balancing a bit. I think, so I explained earlier, there could be like multiple service instances up and running. Right, in that scenario, the Ribbon is facilitating those load balancing in between those multiple services. So it has so much of, different load balancing algorithm which you can implement, round robin, weighted response, and so forth, and you can set timeouts. So those kind of facilities are available. apart from that, actually it also supports you to do the service discovery integrations, fault tolerance, writing fault tolerant mechanisms. So those are the advantage of using ribbon as your intercommunication and the load balancing. So it will play a major role in that. So I think, as I mentioned, like it also support additional features like load balancing fault tolerance, and it supports multiple protocol like HTTP, TCP, UDP, and the caching and batching as well. And finally, so I'm going to present you the microservice architecture in high level, how we have implemented in million space. Maybe even Archana can chip in if there's any further questions. But so we have the front end right now. We have only web. We don't have mobile client as such in million space, and then the Zuul API gateway, and all the authorization does happen in the gateway itself, and then it actually route to the Eureka, which is the service discovery, and then it can talk to relevant service based on the availability and so forth. There could be even multiple services, as I mentioned, available. Then we have the domain, this microservices, like for example, user services, there is space service, scheduler, notification, payments, booking, etc. So those, so it will route to those services accordingly. I mean, this is the high level, and we have database attached to each particular service. I think that's all about what I have to say about microservices and how we actually use microservices in million space. But more details, if you guys need feel that if you're interested in digging more details or get to know about more details about this implementation and microservices, I think we can certainly do that, but not in tech talks, because maybe we can do a tech talk again based on the demand. But I think the first thing is we should actually join the microservice group, which I'm scheduling. So anybody can send me a note, then I can add you to the group, and then there's a group email, so I will add you to that, and then we'll meet regularly and discuss more details. So yeah, so I have put some references also. Any questions, guys?
Hi, Bakthi. The thing is like the Netflix ribbon. Is it on client side, or is it on like in between the server call?
No, actually, yeah. Okay, I get your question. Yeah. So though it's actually being called as client-side load balancing, which it means that, so usually you have the server-side load balancing, which is typically you actually balance the load in between the multiple instances or replicating. You could do that with maybe if you're using cloud, you can do it with auto scale and so forth. But this client-side load balancing is all about, it is happening on the server side, the backend. Within the within the server side itself. So it's
between Zuul and
Zuul,
Eureka.
Yeah.
Zuul,
Eureka, and the other services. Yes, all three will combinedly do that. So all these things are happening beyond API gateway.
Right.
Yeah. So there is nothing in between the client or the API gateway.
Right.
Yeah, good question. Yeah, because it's sometimes confused, like server side, client side load balancing means, nothing related to, browser side. Or sometimes it's actually the name confused. Yeah. It says it happens beyond API. Any other questions, guys? Yeah.
Yeah, Bakthi Prashant.
Yeah.
Can we have a hybrid sort of a model with AWS components?
You mean
like API gateway or AWS?
You mean like we can plug any other API gateway?
Rather than having Zuul.
Yeah, I think we can have Krishanta, but the only thing is certain. If that is the case, certain like the components of the features of the stack will not be used, but it can be used. Then we have to think of like how to handle the other the mechanisms or the out of the box Spring capabilities in a different way. Yeah, but we can replace Zuul with any other gateway as well. And then you can have the boot containers up and running, and then you might have to think about then how you actually does that communication and how you handle service registry, how you handle any other things. Yeah.
So I feel it's most probably if you're running this on AWS, I think Zuul is mostly running on EC2 or something.
Yes, that's right. Yeah, that's right.
So it's being exposed as a public API gateway, right?
Yes, correct.
All right, thanks. That's all for me, and thanks for the presentation.
Okay, thanks.
Okay, thank you, Bakthi. So, hoping to have another Tech Talk session next month. So, thank you everyone for taking part. Have a nice day.
Thanks.
Thank you.
Thanks,